I guess that's Alex. Okay, so then please put it somewhere, and let's maybe in team folder or drive, and let's share it somewhere. Okay, it's recording now. Can you see my screen?
Yes.
Okay. And what the? Yeah, let's try one more. Can you see the slide as well?
Yeah.
Okay. So welcome to the first Firecracker team learning session, which will be regarding Vault on AWS. Most of the things I will be talking about are basically same across all the providers. There will be only few specific to AWS. All right, then let's begin. So let's go a little bit about the overview of the presentation. So first I will just say very basic of what Vault is and what basic concepts it uses, how it actually works, a little bit behind the curtains. Then to the more interesting part, how we install Vault on AWS, and then our use cases. So Vault for the tenant cluster, how we use it and where, and then Vault for the operations, how we use it and which operations do what. Then I will do a little bit demo. So I will just show a little bit about how to connect to Vault, what's on the Vault machine, and these kind of things. And then there will be time for questions. Okay. So Vault, let me just put my other screen so I can see you as well. Okay. Nope. Nope. Back. Okay. So Vault, in general, it's a let's say black box where you can store and retrieve secrets. For example, you can manage authentication secrets. You can manage certificates secrets and SSH of secrets. That's basically lots of functionality that's built on top of the secret. So let's say you save some private key for certificates, and the actual functionality that you can use is that it will generate other certificates from you for that base CA authority. It also can do authentication, so machine can authenticate through Vault to AWS and these some other functionality. But the basic is that you store secret that's encrypted, and they have some way how to retrieve it based on some, let's say, rules or permission that you get. So it can be really nice used as a central place where you can store the secrets for lots of things. So how Vault actually works? Everything in the vault is encrypted. That basically means the vault doesn't even know what's stored there unless you have a way how to decrypt it. At the start, when the vault service is started, it's called sealed. That means that it loads the data that's stored somewhere, but everything is encrypted and doesn't know about how to use them. When you unseal the vault, you basically inject the private key that decrypts the data. Then Vault loads this only into memory and can work and give you the data that you want to work, that you want from there. The sealing process is a little bit tricky. In some ancient times, there was the only way how to decrypt it was manual, so we have usually need more than one person to do this. So they will have to, let's say, when the vault went down, then two people have to go and enter their private key so the vault can be unsealed, and then all the services can talk to the vault again, and it works. The data, sorry. The data are stored in some kind of storage engine. In our case, that's ATCD, that's locally running on the Vault machine, but there are lots of different engine as well. Accessing Vault, it's basically through HTTP API. There's CLI built that will make it a little bit easier to access it, but in general, everything is HTTP request to the Vault and back. Every request needs authentication. That's called Vault token. The Vault token can have lots of different policy or scopes. You can have Vault token that can access everything that's like full admin and can do anything they want. You can have Vault access, a Vault token that only can read one specific secret, or even a token that can only insert new secrets but cannot read anything as well. In the vault, there's lots of different secret backends. They differentiate between the kind of secret that you store. So for example, you have basic secret, which is just string that you insert there. Or you have like the PKI, that's for the certificates. So you store that there's a certificate authority private key, certificate public key, and then you use that for generating certificate. There's SSH, which is kind of similar to the PKI, and there's probably lots of more that I don't know about. One interesting thing is that some private keys of some backends are not retrievable. So if you create a, let's say, certificate backend, PKI, and once it's created, there's no way how you can retrieve the private key of the certificate authority. And without that, you cannot generate the new certificates. So it's like kind of secure that you cannot easily get the data from it, which I would say it's in certain things it's quite nice feature. You can import, of course, new ones, but you cannot retrieve them after that. There's lots of other things that's happening behind and so on, but I don't think it really makes sense to go any much further deeper into the function, how it works. There's lots of videos and documentation on the Vault HashiCorp website, but I think this is for our usage. This is just enough information for start. So how do we install the Vault on AWS? So the first step is we have a repository called Giantess Terraform. Maybe you heard about it before or not. One important step there is it will create the EC2 instance where the Vault will run. We have only one Vault per installation, so this happens only once per installation. One important thing is regarding DNS name. We have, maybe you've seen it somewhere. We have two DNS name. One is called vault1 dot and like the base of the domain, and one is called vault. So usually if there's a number, it refers to certain machine. So if you want to SSH, you would SSH to vault1 dot gorilla dot ucentral, whatever. But if you want to access the vault like API, then you would use the vault without the number, because that's usually mean it's ELB. So it's all balancer. After the EC2 instance and ELB is created, we have Ansible playbook, which is automatization tool Ansible. That install, it's in the Hive repository. Let's install the whole vault. The whole installation is like a little bit complicated because there's basic chicken egg problem with certificates. We use the vault as a source of certificates for the whole installation. But when you want to install the vault, you have no certificates that it could use, right? So that's one thing that this Bootstrap Ansible playbook is doing. So it starts with installing Vault and ATCD. ATCD is running on local without certificate, so it's unsecure. After that, it will initialize the Vault and configure the auto unseal. As I mentioned before, the unseal process needs to be done every time the Vault is started. In our case, because we don't want to do the manual thing anymore, we have something that's called auto unseal. That's connecting to the central Vault in our operation clusters in Gorilla. And with that, there's like mechanism that auto unseal it every time it starts, but it needs some credentials. When the Vault is started, that we will create some recovery tokens. That's some security measures in case the central Vault is locked down or that, and we need to unseal the vaults. And it's done for the Keybase user. So within the Keybase key, you are able to unseal the vault. Then important step is to configure GitHub authentication for the vault. So when anybody who is in the Giants Forum group called Vault admins, then can with his token authenticate to the vault. Then we run some commands to initialize the backends that we use, like TSA, Kubernetes, SSH, and so on. And then we create the main PKI backend for the control plane. That's source of the certificate that it's used for the whole control plane. After that, we generate certificates for the Vault and the ATCD that's run locally. And then we reconfigure the services so they actually start using the TLS. and we have like running them on secure secured by the HTTPS. That's like simplified the way how we install it. Any questions?
The
Yes.
Etsy.
You
Go ahead. Oh, yeah, okay. Then the the etcd, which was mentioned, this is just running on the Vault
Yes.
EC2 instance. So it
Yeah,
has
this-
nothing to do with the
No,
actually.
no.
Okay.
It's just a local etcd. It's only run on the local host, so you cannot access it anywhere else and
Okay.
then from the Vault machine. And it's only for the Vault. Everything there is encrypted, obviously.
Is
Well,
Vault renewing the certificates that it's creating, or is it like a manual action?
No. Vault is basically just API, and you ask for a new certificate. It doesn't look for anything. So in case of the certificates on the machines, we need to be the one who looks, okay, it's expiring, and we need to run the command or generate the certificates again and replace them.
Okay.
All right. So Vault and the tenant cluster. So how we actually use it. So as same as the control plane, it's a source of the certificates for the tenant cluster as well, but it works a little bit different. When there's a cluster creation, then we call to the Vault and create unique PKI backend for each of the tenant clusters. So they have like completely different certificate authority, and this is done by cert operator. Cert operator mostly watch cert configs, which are CRDs, a little bit legacy, I would say, but still in use. And it's similar way, cluster operator create these cert configs for the cert operator to create individual certificates that we need for the tenant cluster. There's lots of them actually, because we use one for API, we use different one for kubelet, we use different one for etcd. Then there's lots of like the certificate that we use for access. For example, Prometheus use that for accessing the API, or all other components that using accessing the API and so on. So then cert operator actually request these certificates from the Vault and then store them in the control plane KS API as secrets. Currently now it's default namespace. Maybe when you have namespaced clusters, then it will be in this different one. But so far it's on default. And you can find it if you just list a secret, and it's always prefixed with the API. So it's in the cluster ID. So it's cluster ID, and there's like the name of what's the functionality. So in this case, example, it's for the API. The next thing that happens, then AWS operator see that these certificates are ready to use. So it will load them, encrypt them via KMS, and injects them into the ignition, which is basically the K8 cloud config thing, and upload it to the S3 for the nodes. And then each node, it is booting, it loads the ignition from the S3, and it has the certificates already there, and the certificates are there later then decrypted by some mechanism. Cert operator itself watch for the expiration of the certificates. We have defined in the configuration of cert operator some TTL. I think currently now it's like 1 month or something like that. So if it sees, okay, these certificates that's stored in the secret, it's going to expire in 1 month, it will ask for a new one. That so it will never expire. But currently, as probably most of you are aware, the AWS operator doesn't roll the machines when this happens. It's actually probably not really something we want, because then we would have like unexpected rolling of the machine or update of clusters when the certificate would be expiring. So far, we don't really want to do that now. Another interesting thing is if you call gsctl create kubeconfig, then you're connecting to the API that's connecting to the cluster service, and that's connecting to the Vault, and it's generating certificates for your kubeconfig, so you can access the tenant cluster API. Any more questions regarding this?
Basically here, the cluster operator, well, the cert operator basically is kind of like cert manager, right?
Yes.
I mean,
Yeah.
we could if you put Cert
In
Manager
general,
with
there was
the Vault backend, it would be more or less the same, right?
yeah, that was one of the ideas back in days that we could use Cert Manager, but it was a really alpha then, and it didn't support the Vault so far. It didn't work. But I think the general idea is the feature just replaces to the Cert Manager. So you create a CRD similar like we create cert config, but different one, and it will connect to the Vault and create the certificates for us.
Mhm.
So and
Cool.
we can drop this one.
And I have one question. So this cluster operator, right? This just like sees basically these secrets, right? Or the AWS operator picks it up, the secrets from the installation, basically, or from the control plane. Like, could it not actually talk directly? So I've like what's the point of just like placing the certs there, and just like you could just also maybe directly
Well,
take
the idea
it.
is like to separate like the components.
Uh-huh.
Like, you know, like you can push basically everything into AWS operator. It can just use connecting to the Vault and get the certificates as it wants. But yeah, it was like the idea that it's better to have like separate component that handle just the certificates, and AWS operator just waits for the secrets
Oh,
when they
okay,
are there.
okay. Because then it's also easier to watch it and just like take actions in case of like something has changed or.
But I guess that then Vault is like the single point of failure, right? If it goes down, AWS operator cannot do anything, right?
Yeah.
But wouldn't it just like only do something in case if something has changed? I mean, if there's nothing to be changed, right? I mean, like in case now Vault is down or so, like the secrets are still there, but it could just like potentially expire or something, and then you just like still have this problem.
Right. I mean, the functionality could be in AWS operator, but yeah, I guess it was not so bad to also have it somewhere else. It can be used for also like different secrets.
Okay, good, thanks.
Okay. Vault and day-to-day operations. So as I already mentioned, it's also a source of the certificates for the control plane, especially for the ATCD that's running on the control plane and also the Kubernetes. Then that's the reason why it's basically also useful for the operations. Usually when you really want to, when you need to authenticate to Vault, then you look the GitHub token, and it works with the good authentication that you send the token, and then the Vault is connecting to the GitHub and using the token to look up your profile, and then it checks your groups. And if it see, okay, this groups is what I really want, that's in case a transform Vault Git Vault admins, then it say, okay, this is full admin, and I will give him back like Vault token that's scoped for admin across the whole Vault. These tokens are short-lived, so basically use your GitHub token to authenticate, but it will give you token that's like working for, I don't know, a few hours, and after that it's expired. So it's kind of a good mechanism that you don't really use in like the real token. And if you copy it or use it somewhere, it's going to expire anyway, so that's fine. So if you call obctl create kubeconfig, then you are talking to Vault, and you're asking for, you basically generate certificates to the kube control plane API, and these certificates are then used to create the kube config that you are then using. So every obctl create kubeconfig is connecting to the Vault. A similar thing happen if you call obctl ssh somewhere to some installation and some node. This is a little bit more complicated, but it basically generates SSH certificate for you that is used for the authentications. And you use that SSH key in your SSH again, it's automatically added by the obctl. And then when you connect to the control plane node or the tenant cluster node, this SSH key is the one that will confirm or allow you to access to it. What's interesting is that the SSH cert that you are using for the SSH has actually TTL, and it's kind of short. It's like 1 hour, maybe a little bit more. That means when you can generate SSH cert, but when we remove the GitHub access to you, then you cannot generate a new one, and the old one will expire soon. So basically, all your SSH access is gone, which is kind of nice. So you cannot just create SSH keys around, and even if you leave company access anything. And the way how it works is on the SSH certificate authentication is that on the node there is some CA that confirms that the SSH key you have is actually valid and the one that it requires to allow you to go to the node. Any questions here? Okay.
Does this mean you don't need to have your, like, you don't have to provide your SSH key? What is the reason why we have to place our SSH key?
The problem here so far is the Bastion's host, because the vault is hidden. You cannot connect to vault directly, and you need to go through Bastion. So you need like your personal key on Bastion, so you can go through that, and then you connect the vault. Once you have the vault, you can get the generate SSH key. Then you can go just from the shortly generated cert. But yeah, there's an idea how to get rid of it as well, so you don't have to actually have SSH keys anywhere. Okay, and it's demo time. I have 5 minutes. I'm not sure if they're gonna be that fast, but let's try at least anyway. Can you see my terminal?
Yes.
Okay. Let me open my cheat sheet. Okay, so I'm just gonna go obctl ssh real vault. Can SSH there. Now it's doing the process of generating the thread through the vault and connecting to the vault, but fine. Okay. So I'm just gonna, if you call SSH add and L, you can actually see, no, the key. So this is your private key, and this is private key for the SSO, for the SSH, for the joins form, and this is the certificate. So you need basically all the three to actually go there, and it's forwarded by the SSH agent. Yeah, so let me just show you what's actually here. So we're using the systemd unit for here, and the important one are the etcd and the vault. The etcd, as I already said, it's running on localhost. There isn't like that much interesting thing, but just good to know that it's running here. As you can see, it's running since very long time. And the vault, yeah, this is similar. It is a version of the vault if you are anyhow interested into that. As you can see, yeah, sorry, it's running as well. If you want to check the logs, you can use journal CTR for the the vault, but I assume there's not going to be anything useful. Yeah, so far, because this is just the general logs, and this is error you maybe see often. It's the ELB check, but there are actually logs that can be interesting in the vault log, and it's called vault audit logs, where actually it's sort of definitions. Like every operation that you do, it's logged here. Here you can see there's a policy from cluster service, so that probably cluster service assessing the vault and trying to do some operation. Operation is read, so it's probably just checking something. So every operation is logged here, so it can be audited if necessary. Vault configs are in etc vault, which is, there's also like all those test files and certificates, as you can see, but the config is only interesting is the configuration for the backend. So it knows where to connect for the data, is connects configuration where how it should listen, and this is configuration for the auto unseal You can see there's the vault operations, the vault central vault for that. If you want to talk to vault, usually there's also here like binary, or let's say the Docker image that you can use. You can check the vault status. But if you want to talk to vault, I would probably not recommend you doing from here. I would rather recommend using a command. Maybe you not know if it exists, but it's called obctl create vault config. Sorry, wrong flag. And you only need to have vault binary on your machine. This will create the config for you. You can just copy paste the values. And now if you call vault, it will talk to the vault on the installation that you ask for. And now, yeah, you can start to run commands like vault secret list and so on, and it will show you like the backend, the most list of the secrets that are all created. These PKIs, that's like the cluster. That's certificates for each of the cluster. You can see ID here. There is backend for the SSH that we use for the SSH. And maybe this is also interesting. This is the G8 PKI. It's used for the control plane. And there are a few more others as well. And that's going to be end of the demo. And that's all. Any questions regarding anything?
Like you mentioned before that the Kubernetes backend is defined somewhere, right? Where is this? Like because you're just showing only etcd was the backend. Is there any example?
Yeah, it's somewhere. I think it's one of these. I'm not completely sure because it's not really shown. But the Kubernetes backends, it's kind of a new thing that we're starting to use recently. Mm-hmm. But it's not like the backend as like you would be storing secrets from Kubernetes to the vault, which is like the functionality, but we don't do that. We use like more like authentication through the KAs. So the service like cluster service or like what's running in our control plane is not using tokens for like the normal tokens, but is using a KA's authentication to get to the vault and get the secret back. So it doesn't. We don't have to like renew the vault token every few months as we have to do it before. So that's the functionality for now.
Okay.
Anything else? Okay. Do you have something for Paul?
No, it's pretty cool.
Okay.
The setup.
Cool. So I will stop recording here.